our new unit. So we are starting unit 7, and we are at 7.1 through 7.3. So we're kind of mushing them together because they overlap, and it's okay. So exponential function attributes and transformations. So we're going to start by talking about our first function here. So as you can see, we have this picture of this graph, and this graph represents an exponential function. Exponential functions are written as f of x equals a times b to the x. Okay, it's an exponential because your variable is now your power. Okay, your variable is now your power. The power is what's unknown. Okay. So for this example, because there are 3 variables that are unknown, we're going to let a equal 1 and b equal 2. So the function that we're focused on, so we can graph and analyze, is f of x equals 1 times 2 to the x. So basically 1 equals 2 to the x. Okay? So that's what this graph represents. It represents 1 equals 2 to the x. So let's analyze. We're going to talk about parts of it. Notice here how the graph never crosses the x-axis. The graph never touches the x-axis. That's because it has a boundary line, an imaginary boundary line that we learned about in Algebra 1. Does anyone remember what that boundary line is called? An asymptote. It has an asymptote at y equals 0. Okay, it has that boundary line at y equals 0. We're going to keep analyzing. We're going to look at some key features here. As you can see right here, my only intercept that I have is a y-intercept, and it's at 0, 1. A key value here is at 1, 2. And then I have another one here at -1, 1/2. Okay. So let's talk about the domain. Remember, our domain is asking us from left to right. So what is happening horizontally? So from left to right, what's happening? How far left does my function go? All the way to -infinity, right? And then how far right does my function go? All the way to positive infinity, right? So our domain is -infinity to positive infinity, which means that x is all real numbers, right? So our x is all real numbers. All right. Our range, how low, so range again is bottom to top. How low does our function go? It never goes below 0 because it never touches 0. Instead of a bracket, we use parentheses because it'll never touch 0. Remember, bracket means it's included. Okay. And then it goes on forever to infinity. Okay. We can't contain infinity, so we write it with parentheses. So writing this as an inequality, it would be y is greater than 0. Not equal to 0, but greater than 0. Looking at this graph and analyzing it, what is our intercept? The only intercept we have is a y. There's no x-intercept. There's only a y-intercept, and it's at 0, 1. Okay? When you're talking about your asymptote, we have an asymptote. We have a horizontal asymptote. And the horizontal asymptote is at y equals 0. And this graph, it's increasing because just like a book, we read a graph from left to right. And from left to right, this graph is increasing. Okay? To write this in mathematical terms, we write it as x goes to positive infinity, f of x also goes to positive infinity. That's what it means. So as my x values increases, my y values increase. Okay? Because of this, when you're analyzing the graph and looking for a max and minimum, it's going to always be the endpoints, depending on where you're at. Okay? Now, we call this a growth function. The reason why it's called a growth function is because it's growing. It's steadily growing, and it's growing fairly quickly. Does that make sense? All right. Now, the decay model. So looking at the decay, you can see that it's declining really fast, right? This time, if you look and see, we are still using the exponential parent function, a b to the x. We're going to let a equal 1, b equal 1/2, and our function is f of x equals 1 times 1/2 to the x power. Okay? This 1/2 is what makes it a decay. So instead of multiplying repeatedly, we're now dividing repeatedly. Okay, I'm cutting it down. But looking at its attributes, notice how it still doesn't do what? It still does not touch or cross the x-axis at y equals 0, right? So it still doesn't touch or cross. We're now going to look at some of the key features here. So I have my only intercept is right here at 0, 1. I have a key point right here at -1, 2. And I have one right here at 1, 1.5. Okay? Did my domain change? No, the domain is still all real numbers, right? Did my range change? My range is still greater than 0, not equal to 0, but greater than 0. Did my intercept change? Nope, still only 1. Did my asymptote change? Nope, still at y equals 0. But what did change is reading this graph from left to right, what is it doing? It is decreasing, okay? And we say that it's decreasing because as my x's go to positive infinity, my f of x's are going towards 0. They're getting smaller, right? They're not trying to get larger. They're heading towards 0. All right. So notice here that your values depend on what your base is of your exponential. So when I look here, my 1/2 is my value at 1. So my value at 1 is what my b is, right? And then my value at -1 is the opposite, is its inverse. It's reciprocal, not inverse, sorry, poor word. It's its reciprocal. So if we go back and look at this one, notice here, my value at 1, is that not my b value? My value at -1 is its what? Reciprocal. It's the 1 over b. Yes? All right. So what I would like for you to walk me through here is that we're now looking at this one. So we have f of x equals a b to the x. But this time, a is still 1. So because a is still 1, what we just said still should hold true, right? But this time, b equals 10. So knowing that and looking at this graph, I should be able to identify some key points still. So I still have my asymptote, right? Okay. What should be at -1? What value should be at -1? Even though I can't count it and I can't see it, based on the patterns and rules from the previous two, at -1, the value is -1/10, because it's the reciprocal of what's at 1, which is my b value. So even though I can't see it and I can't count it, that value right there is -1/110. At +1, it goes off the page, right? It goes off the page, but at 1, it's going to be 10. Here, still the same. Okay? So, again, the reason being is that if you think about this mathematically, what's anything to, if I to the 1 power, what's anything to the 1 power? Anything at the 0 power is going to have a y-intercept at 1. But anything to the 1 power, if I have 10 to the 1, isn't it 10? And that's why it's the value of your b is what 1 is, okay? All right, so your domain, did that change? Nope. Our range, did our range change? Our intercept, did that change? Nope. Did our asymptote change? And what is the graph doing? It's a definite increase. So as x goes to positive infinity, our y is going towards positive infinity. Okay, so if I'm in the standard form, and if I'm in my parent function form, and my a equals 1, then I'm going to have these rules, right? I'm going to follow these rules. Okay, let's see how this holds up. What we have now, we're introducing our natural base exponential function, okay? And what that is e. And e is kind of like pi. You know how pi has a value, 3.15145, okay? So same thing here is e. E is approximately 2.71828, okay? But instead of writing that out, we just have e. And so this is called our natural base exponential, okay? So our function here is f of x equals 1 times e to the x. And again, e is a number, just like pi is a number. They have value. So using the previous things that we said about exponential functions, we still have our asymptote at y equals 0. We still have our intercept at 0, 1. Now, to find the value of our 1, we don't know exactly what this decimal is by counting it, but we can identify that decimal by using a pattern that we just established. So at 1, it depends on what your base is. And what is our base? Our base is e. So the value here at 1 is 1, e. The value here at -1 is the reciprocal of that. So at -1, we have 1 over e. This is to show you that the rules still may stay the same, that they are true rules, they exist. Our domain is still all real numbers. Our range is still y is greater than 0. Our intercept is at 0, 1. Our asymptote is at y equals 0. And this is a growth. It increases as x goes towards positive infinity, y goes to positive infinity. I should have wrote f of x. I got lazy. Okay. Was that terrible to analyze the graph? Not bad, right? So let's summarize it. So summarizing it all together. For the function y equals ab to the x, the intercept depends on your a. So if your a changes from 1, guess what's going to happen to your intercept? It's going to also change, okay? So your y-intercept depends on your a. The domain is going to be all real numbers all the time for every last one. The asymptote is going to be at y equals 0. And the range is going to be y is greater than 0. Whether it's a growth or a decay depends on the value of your base, okay? Whether it's a growth or a decay depends on the value of your base. And so when I look here, if b is greater than 1, then it's a growth. If b is between 0 and 1, then it's a decay. Okay. I also want you to remember that how to identify the table. So in terms of a table, you have 1, and your 1 is based off of your b value. You have your 0 is based off of your a value, and you have your -1, and your -1 is the reciprocal of your +1. So that's how you find your 3 parent function points, okay? Because your a and b can change, your table is going to constantly change as well. All right. Okay, so let's do some analyzing practice. So you have the function f of x equals 2 to the x, and I want you to use the graph to determine the coordinates of the maximum and minimum values of the function on the given interval. So just like when we did the square root and you identified maximum and minimum, because the graph is forever increasing or forever decreasing, your maximum and minimum depends on the values of your endpoint, okay? So I'm going to pause for a second, let you use the graph, analyze the graph to make sure that you understand how to read the graph and that you're comfortable with it. All right, so checking your analyzing of the graph. If I have f of x equals 2 to the x, which is our first graph, our growth function, and I'm looking at between -2 and +2. So looking between -2 and +2, let me hop back to that graph really quick. So looking between -2 and +2 is where I'm going. I'm going to highlight. So here and here. So highlighting there, I want to know what's the minimum and maximum value. So we can clearly see that our minimum is here at -2 and our maximum is here at +2. Agreed? And in value means we want to know what is that y value? What is that number that's there? So at -2, I am at 1/4. 1, 2, 3. Yeah. So this is divided into 4. So at -2, I am at 1/4. At +2, clearly to see, I'm at 4. So therefore, my max value is 4 at x equals 2. And my min value is 1/4 at x equals -2. Do you see the relationship between the 4 and the 1/4? Do you see how they are reciprocals of one another? Yes? Okay. So if you didn't have the graph, mathematically what you could have done is you're substituting in -2. So if I have 2 to the -2, that means that I have 1 over 2 squared, which equals 1 over 4. Isn't that what the graph told me? If I didn't have the graph, that means I'm substituting in f of 2. And 2 to the 2 squared equals 4. So same thing that I could possibly do looking at the graph. If I didn't have the graph, here I am. So if I have the next graph, f of x equals 1/2 to the x graph to determine the coordinates. So looking at my decay graph, I want to know where's my max and where's my min. So going back to my decay graph, so from -2 to +2 is what I'm analyzing. So at -2, I'm at 4. At +2, I'm at 1/4. Okay. So here we have our max value is 4 at x equals -2. Our min value is 1/4 at x equals +2. And that makes sense because this one represented a growth. As my x's increases, my y's increases. And this one represented a decay, right? As my x increases, what did my y's do? They decrease. Okay? And using that same logic, if I didn't have the graph, remember, we still have those math skills. We're still able to substitute values in and calculate. So if I have 1/2 to the -2, that equals 1, 2 to the -2, which means that it should be 2 squared, which equals 4. We still have these skills that are in our basket. Okay? So there's always a way to solve the problem if you use all those resources that are available to you in your brain. Okay? But we have the graph, and it wanted you to look at the graph, right? Okay, how do we feel about it? Okay. All right, so that's part 1, which was analyzing.